Hello friends, today we are going to learn about critical path method, a very important method for PMP and operation management. So let's get started. Critical path method is also known as activity on node, AON. It uses nodes to represent the activity, uses arrows to represent precedence relationship. Here are examples of the network diagrams. In the first diagram, activity A precedes activity B, which precedes activity C. So this is just a simple one. Second one is activity A must be completed before activities B and C can begin. Third one is activity A and B both must be completed before activity C or D can begin. And activity this one in this diagram, activity B and C can begin only when the A has completed, and activity D can only begin when B and C has completed. So I hope you got the idea. It was very simple. Let's do an example to understand how critical path method works. So first of all, we should define a project. XYZ company is bringing a new product online to be manufactured in their current facility in existing space. The owners have identified 11 activities and their precedence relationship. Develop an activity on node for the project. So these are the activities. These are the description of activities. These are the immediate predecessor, and this is the duration. So looking at this, what we need to do is we should start drawing the diagram. So first is the, activity A, develop the product specification, which has a 4-week duration. So we will draw a circle which will define as activity A with duration of 4. First, we'll just draw the diagram without the duration. So activity, first it has to start with activity A. Then design the manufacturing process, which says that A must be completed. Then only B can take place. For C also it says A must be completed before C can take place. So after A, in parallel B and C can start. So after A, B and C can start. Let's go back. D. D can start only if B has completed. So after B we can write, sorry, after B we can write D. We see this activity E can only start when D has completed. So after D, E, we can write E. F can only start when C has completed. So after C, F. G says both E and F should be completed. So E and F should point to G. E and F pointing to G. Then H. H can start only if G has completed. Similarly, I can start only if G has completed. So after G, H and I both can take place in parallel. H and I both can take place in parallel. J can only be started when H and I has completed. So H and I both should point to J. And K can only start when J has completed. J has completed and K. So this is the network diagram for XYZ company. Let's see. Now putting the duration, looking at the table which was given before, we have put the duration. A has taken 4, 6, likewise. So what we need to do is first find out the connected paths A, B, D, E, G, H, J, K. This is one connected path. Second path is A, B, D, E, G, I, J, K. Third connected path A, C, F, G, H, J, K. Fourth is A, C, F, G, I, J, and then K. These are the four connected paths. Now adding the duration of each of the connected path, all these, the duration which is given in the bracket, we come up with these numbers. The path 1 has 40, path 2 has 41, path 3 has 22, and path 4 has 23. So the longest path is the second one, A, B, D, E, G, I, J, K, which takes 41 minutes or hours, whatever it is, or days. So the longest path is the one which we will call critical path, because we cannot complete this project in less than 41 hours. So the longest path is always becomes a critical one. Some of the network definitions. All activities on the critical path have zero slack. Whichever is the critical path which we calculated in, it has zero slack, meaning we cannot delay any at any point. If we delay at any point in the critical path, the project is going to delay. So it has a zero slack time. Slack defines how long non-critical activities can be delayed without delaying the project. Slack, the activity's late finish minus its early finish, or its late start minus early start, it must be zero for the critical path. For other paths it can be anything else, but for the critical path it must be zero. Early start is equal to early finish of the immediately preceding activity. Earliest finish is the ES plus the activity time. LS, which is late start, and late finish, LF, is the latest activity can start LS or finish without delaying the project completion. This is forward pass. Forward pass means finding early start and early finish for each node. And this is the formula you can remember. Logically also you will be able to find what is early start and early finish. But if you have less time, you can use just this formula. Remember this formula, EF is equal to ES plus duration minus 1. So early start is we start at 0 time for activity A. Then we move, it takes 4 hours. So what we need to do is, we should add early start for A is 0, then it will finish at 4. So as soon as this finishes, B can start. So early start for B is 4. And then it takes 6. So 4 plus 6 is 10. Early start for D is 10. Then again early start for E is 10 plus 6, which is 16. 16 plus 14, which is 32 for this one. No, it has to go this way. 16 plus 14, 16 plus 14 is 30. So G can start only at 30. But we have to check from this side too. Early start for A is 0 and early start for C is 4, because 0 plus 4 is 4. For F is early start for C plus the duration of C. 4 plus 3 is 7. So F can start only if C has completed. So it can start at 7. When can G start? Can G start at 7 plus 5, 12? No, because G has to wait for E to be completed. And E can complete only at 30. And when it completes at 30, G can start. So there is a slack time in from moving from F to G. So similarly, for H to start, G has to finish. So G started at 30, and it takes 2 hours. So it becomes 32. So only at 32 the H can start. When H can finish, H can finish as 32 plus 2 is the duration of H, so makes it 34. So it can end at 34, and J can start at 34. Let's see whether it cannot. We have to check for both the path, because J can only start when H and I both has finished. So here G finishes at 32, and as soon as G finishes, I can start. So I can start at 32. It takes 3 hours. So 32 plus 3 makes it 35. So at 35 I will finish, and H will finish as 34. So which is the latest? 35. So J has to wait until both are done. So at 35 J will start. So there is a slack time between H and J. So J can start at 35. It has duration of 4. So 35 plus 4 makes it 39. So early finish is 39. At 39 K can start, and it has duration of 2. So its early finish is 41. 39 plus 2 is 41. So this is the forward pass. I hope you understood. Let's do the backward pass. Backward pass is late start and late finish. And the formula to remember is LS equal to LF minus duration plus 1. So if there is a less time, you can just use the formula and just keep calculating, because logically also you can do it by adding manually, but if you have less time, you can just follow it. This is similar to what we have done before, but it starts from back. So we have early start and early finish times. So for the last activity, we can use the same as before. So late start is 39, late finish is 41. So moving backward, late start is 13. Late finish is how much? It can be whatever is the late start date. The same thing will come here, 39. And late finish, late start is just 39 minus 4, the duration. So it will come as 35. So 35 is similarly, you can use this formula. It's very easy, and you can do for each node, and you will find the critical path as same, which we calculated in the you can pause the video and do it by yourself, and I think you will be able to understand what is it doing exactly. Total slack or total float formula is LF minus EF or LS minus ES. You can calculate for each of the node, you can calculate the slack time, slack weeks. So like for this one, for activity A, late finish is 4 and early finish is also 4. So LF minus EF is 0. So there is on activity node, the slack week is 0. For activity C, the late finish is 25 and early finish is 7. So there is slack week of 18, there are 18 weeks slack. So for each node, you can find out the slack timing. And there is one more concept called free slack. Free slack can be calculated as early start. Free slack is the amount of time an activity may be delayed without delaying the early start date of any successor activity. And it can be calculated as early start of next node minus early finish of the current. So you can just memorize this formula and use it whenever needed. So guys, I hope this gave you some insights on the critical path method, and if you practice a few examples, you'll be able to understand more. And subscribe to my channel. This is my channel for more videos on different geek topics, PMP tutorial and other things. Thank you very much for watching.